Okay, so for this, while it's loading, I hope it doesn't freeze. There we go. Okay, so you guys got a few questions here we're going to go through to practice doing the forces we were talking about today with the normal force and the force of gravity, as well as adding on one more type of question that isn't going to be too hard, but I want you guys to try. So I'm going to have you pause the video. The Edpuzzle is going to pause. You're going to try this first one. Given a person that has a mass of 55 kilograms sitting on a chair, do that one. And then you're going to click continue when you're ready, and I'm going to go through it. You're going to do that for each question. Okay, let's check this. So we are looking for the magnitude of the normal force and the magnitude of the force of gravity. Now, if we recall from class, we talked about this. The magnitude of gravity is just mass times gravity, right? Because F equals ma. In this case, a happens to be the acceleration of gravity. So for the force of gravity, I'm actually going to start there. This is going to be mass times the acceleration due to gravity, 55 times 10. That's it. So you got 550 newtons. Now for the normal force, though, remember that in this case, we have a person sitting on a chair. So it's a flat surface. Here's gravity. Here's the normal force. So because this is a flat surface, the normal force is going to equal gravity. That's because it is a flat surface, and only because it's a flat surface, you should have gotten the right answer, the same answer for both. Force of gravity is only a y component here, so they're equal. Now we have a situation here where gravity is not going to be a strictly y component. So go ahead and read this question. This is going to be one where we need to break it down and find the y component of gravity. Okay, so the magnitude of gravity is always mass times g. Again, this is F equals ma. Ra just happens to be gravity. 23 times 10, 230 newtons. Now, however, when we go to draw our force body diagram, which I really should have done first, we have a kid on a slide angled up at 45 degrees. Now, here's the normal force coming out of our surface. Here's the force of gravity. And here is the y component of gravity. That's what the normal force is. It is the y component of the force of gravity. I want to emphasize that because I didn't do a great job in class. We can go straight here. So our 45 degrees is always in between the gravity vector and the y-axis. That 45 degrees is in between the gravity vector and the y-axis. So I'm going to take this triangle here, and I'm going to pull this triangle off and recopy it so that gravity is my hypotenuse. 45 degrees is up here, and force gravity y is right there. Again, I just took this triangle and I went and I tilted it. My right angle is right there. Okay, so again, we know what the force of gravity is because we already found it. We found it to be 230 newtons, so I'm going to erase that. Force of gravity is 230 newtons. Now, again, y is now the adjacent, so we should be using cosine. For a long time, we've been doing sine for y. It doesn't always work that way. Because y is the adjacent, this is going to be the force normal. It's going to equal the y component of the force of gravity. We should be 230 cosine 45. What do we get for that? 230, oops, clear. 230 times cosine 45 should get 162.6. When we're on an incline, the normal force is always less than the force of gravity, and we're going to talk about that later. Okay, so this one we're going to try together because this is a little bit new, but it's not going to be very tricky, and then you're going to try one more by yourself as well, I believe. I got a few more. Okay, let's try this one together. A man is pushing a 10-kilogram box on carpet with a force of 125 newtons. If the force of friction fighting against the movement is 100 newtons, how quickly will the box be accelerated? So this is new. So let's draw our diagram. We have a box on carpet. A man is pushing it. It doesn't matter which direction, but I'm going to go ahead and say pushing it this way with the force of 125 newtons. Friction is fighting against it. This is going to be the force applied. Friction is fighting against it at 100 newtons. The question is, how quickly will the box be accelerating? Well, we have a formula where we have A, F equals ma. But what we need to know is the net force. This is the net force equals ma. That's because, again, even though he's pushing with 125 newtons, friction is fighting against it with 100. So to start with, what is the net force here? Keep in mind, this 100 is in an opposite direction from the 125. We'll call it negative. One is positive, one is negative. What's the net force here? 25 newtons. We need to add these forces together. And I'm adding a negative 100 newtons, so really I'm subtracting. This is my net force, 25 newtons. So this box is actually being pushed net with a force of 25 newtons. So if I have F equals ma, my force is 25. That is actually net pushing the box because friction's fighting against it. We have a mass of 10. We need to solve for its acceleration. So we divide by 10. We would get an acceleration of 2.5 meters per second squared. So find the net force. Again, net force means with my negatives and my positive signs, what does it end up being? I plug in my force and the mass of the object, and I can find how fast it's accelerating. Go ahead and try it on your own now on this question. Okay, so let's draw a diagram. So our diagram here, two people push a heavy container along a ground. One with a magnitude, I'm going to go ahead and push this direction again, of 200 newtons. And the other pushing the same direction. So we have two vectors going in this direction. They're pushing it together. Friction is fighting in reverse, negative 300 newtons. Now, hopefully you kind of realize this. I wanted you to see if you can figure it out. If I have two forces going in the same direction, those are both positive. They add together to get the total force going in that direction. So my net force, whatever, I'm sorry, let's erase that. Equals, I have a positive 200, I have a positive 150, and I have a minus 300. This is my net force, is going to be 50 newtons. So that is the force that it is actually moving with. Because again, the friction is fighting against it, and they're pushing with only 50 extra newtons than what friction has, yeah? So F equals ma. If I'm trying to find acceleration, my force, my net force goes there. My mass, which is, whoops, I need to describe the heavy container here. Let's go ahead and call this container, I'm sorry, this is my fault. Let's say this container is 30 kilograms. You might have paused the video and then realized you couldn't do it. 30 times acceleration, divide by 30, divide by 30. It is accelerating. 5 divided by 3. 1.67 meters per second squared. So once again, with these questions, find the net force. If the question says, how fast is it accelerating? Find the net force, plug that into F, plug the mass in when you're given it, and then divide to solve for acceleration. So I want you to try this one more. This one's going to be a little tricky, but again, keep in mind, just like we did here, you can have two forces going in the same direction. So keep that in mind, read this question. You already drew the force body diagram for this for your homework. Now we are going to find the acceleration of the treasure which is going to involve us knowing the direction it's traveling. We'll talk about that, but go ahead and give it a shot and then come back and check. Okay, let's draw the FBD, the free body diagram. So here's my treasure. I'm just going to draw it as a dot. The boat is pulling up. We would call this the force tension of being pulled up with an upward force of 4,000 newtons. However, the mass of the treasure is 200 kilograms. So this is Earth, do not forget. Gravity is still pulling down. Yes? So force of gravity equals mass times gravity, 200 times 10. We have a downward force here of 2,000 newtons. That's the force of gravity pulling the treasure down. Now the water also is pushing down on the treasure, resisting the force by the boat pulling it up of 1,500 newtons as well. Since that is down, that is going to be negative as well. So here's what we have. The boat is trying to pull it up at a force tension of 4,000 newtons. Gravity pulls down with 2,000 newtons, mass times gravity. And then the water is also pressing on the treasure because it's heavy. And so that's also a downward force. So let's find the net force. Force net equals 4,000 upwards minus 2,000 of the weight of the treasure minus 1,500. This is going to give us a net force of 500 newtons, and it is going to be upwards, but it's positive. So F equals ma. It's being pulled up with a net force of 500 newtons. Its mass is 200. We want to find acceleration. This should be, I believe, 2.5. Yes, 2.5 meters per second. We're going to practice that a little bit more in class, but hopefully that makes sense on what we're doing. Find the net force, plug it into F equals ma with the mass, solve for acceleration. We're going to practice that more in class.